don't shy away from conducting performance-based evaluations for deviations from the standard practices. Every facility is different. A well-designed study can really support changes that make a substantial improvement in operations.
Hello and welcome to The Last Word, the official AALAS podcast dedicated to advancing laboratory animal science. I'm Jennifer Smith, Chief Scientific Officer at AALAS, and also your host. Together we'll discuss current research, emerging trends, and the innovative work that supports scientific progress with animal welfare. We are so glad you're here. Let's discover something new together. Welcome back. In this episode, I am joined by Alyssa Valentyn. Alyssa is the Supervisor of Vivarium Services at Eisai US. She received her BS degree in Environmental Science and Biology from St. Michael's College and has been employed at Eisai for the past 5 years. And Alyssa is joining me today to discuss her recent JAALAS paper titled Extended Sanitation Frequency for Bottles Using Volume as an Alternative to Time-Scheduled Replacements for Mice in Disposable, Individually Ventilated Caging Systems. Alyssa, I am so glad that you're joining me today. I love the paper. I just can't wait to hear more. So I'm going to turn it over to you, ask you to introduce yourself and just tell us about yourself and, how did you get interested in doing what you're doing?
Well, first of all, thank you for having me. It's a pleasure to be here. I've been on a bit of a unique path to get into the field of laboratory animal science. Like you said, I graduated from St. Michael's College with a bachelor's degree in environmental science and biology. So I was originally intending to become an ecologist and maybe more specifically a botanist. My undergraduate work used trail cameras to capture animal distribution in the landscape, which was classified using plant diversity. So it wasn't until my second field season after undergrad that I began working with small mammals. I started monitoring populations of wild field mice, voles, chipmunks, and shrews in New England. And I realized that I really loved working with the wild rodents. And I began to love working with rodents in general. So I was looking for a full-time career that would expand these specific hands-on skills, and I had a friend point me towards rodent husbandry at Eisai. Eisai has been a very supportive environment to pursue these hands-on skills and look at improvements to animal welfare using, investigation. So yeah, Eisai has been a very supportive environment, and we've been pursuing a lot of improvements to animal welfare using just thorough investigation. And my background as an ecologist has actually been very valuable in designing, observational studies to improve on these best practices. So I've been on a wide range of projects from examining nest scoring as an early metric for pregnancy in mice. I've done some work refining a cerebrospinal fluid collection procedure in mice, and then this study on extending the sanitization frequency in water bottles.
Oh, I love that. I think you might be the first person I've had on the podcast that came into our industry that route. And I just absolutely love the connection between, ecology and other wild-caught animals, if you will, to then putting that into practice in every day what you do at Eisai. And I just love it. And I love that your company is so supportive of using your past skills in your current job. I think that's wonderful. So I have to ask you, on those trail cameras, what is the most interesting animal you've ever seen?
I think the most interesting capture that we've had has been a bobcat that actually marked our camera. Didn't know that at the time. So when I went out to collect the SD card, I wiped what I thought was just moisture off the lens. And then I looked back and realized that was bobcat urine.
Oh my goodness. I do. Sorry about that, but I love that story. I have a friend in northern Michigan where I'm from, and she loves to send trail cam pictures. And I find myself being very stressed before I open them because I'm afraid of, one's a wolf, one's a bear. You just never know. So I'm glad I don't have to touch the camera itself, though.
Yeah.
All right. Well, that's so fascinating. Thank you for sharing that. We love the stories. We love to hear from the people who do this great work and celebrate the work that you do. But we also just love to hear your story and how you got into it. We're all on this journey together for sure. All right, so we know it takes a team to do a project like this, especially something like this that's robust, has a lot of different details and variables. So we would love for you to introduce the team, tell us who did what and why.
So this project involved a really great team, so I'd really like to thank everyone, if that's okay. We have Venus Estrada and Naina Silva, our vivarium technologists, and they do the day-to-day husbandry, vivarium operations, and they were essential for the data collection and animal care on this project. Jackie Ollie Williams and Ying Wu are data scientists. They were extremely helpful in determining sample size and running statistics and data analyses. Misty Williams Fritz is our attending veterinarian, and so in addition to editorial support, Misty advised the metrics to inform our animal well-being throughout the study and provided veterinary guidance and interpretation of these metrics. Courtney Easley Neal is the director of our translational models department, so she provided the institutional and editorial support. And then last but definitely not least, Lorette Burgess is our associate director of vivarium operations and my manager. She is responsible for our program, and she's been absolutely instrumental in our pursuit of excellence in animal welfare. Lorette was heavily involved in this project's study design and provided both institutional and editorial support for this project, and I couldn't have done it without her.
Oh, that's fantastic. You have a great team there for sure. And some of those names we know in the AALAS family, and I'm just so thankful that you guys were able to work together and get this great work. This is one of those papers that I think people will be looking at and saying, how do we find out more? How do we apply this to, our situation particularly? All right, so I guess let's jump into the introduction. You did a really nice job of summarizing, not only the more, quote, modern equipment with, the regs and just kind of some of the things that we should know. So it would be great if you could just sort of take us through the highlights of your introduction. And then we always ask our guests to sort of zero in on that hypothesis and what you were really looking to do in this paper.
Sure. So we had 3 goals in mind as we set up our project. First, to reduce plastic and water waste. Second, to improve occupational health, reducing the ergonomic strain associated with bottle replacement. And third, to improve operational efficiency by streamlining husbandry tasks. So at our institution, we use a disposable IVC caging system, and this works really well for us as a small institution with limited space. But as an environmentalist, I saw an opportunity to reduce environmental impact without compromising the animal welfare. And so we've been using the system for over a decade. The bottles arrive pre-filled with acidified water, and they're single-use only, so we don't refill them. At bottle replacement, we'll empty any leftover water and recycle the plastic. So with weekly bottle changes, we realized we were replacing bottles that were mostly full. We were also facing a misalignment in our scheduling. So what if bottles are scheduled for Thursday, but then we get a shipment of mice on Tuesday? Do we change the bottles on Thursday, even though they're only 2 days old? Or do we wait until the following Thursday at 9 days old? And so it's not long before the whole room is out of alignment, which makes the job of the husbandry technician very difficult. We also suspected from the bottle's design that there may be less potential for contamination of the water. And so we designed an initial pilot test to extend our bottles to 14 days instead of 7. And this would align with our biweekly cage change schedule. This pilot study was supported by similar metrics of animal health and water quality, but ultimately, while this 1-week extension did reduce waste, it didn't address the issue of misalignment and the need to date and track that bottle. So, for example, as part of our emergency response plan, we never go below 100 mils of water. And this represents an approximate 4-day supply for a densely populated cage. One thing that became apparent from our 1-week extension was that in high-density cages, some bottles reach that lower 100 mil limit sooner than 14 days. And so now on an individual basis, we now had to track these bottles as they became misaligned with the cage change schedule again. So our next observation in question was that the bottles are clearly marked for 100 mils, and we already check for and replace these bottles on a daily basis as part of cage checks at 100 mils. So why not just use this volume across the board to spot change all bottles? And so we hypothesized that in the system, the water would remain palatable and free of contaminants while the mice remained in good health, and so we designed the study from there.
Oh, that was so well said. What I really love most is just you guys, your group's ability to overlay this kind of, what are the regs saying? What is everybody else doing with, hey, what's happening in our shop? Like you said, the misalignment. I love that. And I love those, creative problem solving, if you will, of just like, hey, this is not working for me. So kudos to you guys for really figuring out like, hey, we gotta get some data here. I love it. Okay, so let's jump into the design, kind of materials and methods. You got a lot of parts and pieces. So go ahead and maybe summarize that for us.
Yes, so we used some metrics to evaluate animal well-being, which are just the tools that we use on a daily basis. So this would include body condition score, activity levels, coat quality, overall appearance. We also measured the body weight to make sure that the weight trends continued as expected. And then we measured water rate loss, and that was a proxy for consumption. So just a side note, these mice were not in metabolic cages, so we can't say for certain that the water loss was consumed. But taking that into consideration, the rate of loss should be consistent over time. So if the water is not palatable and the mice are drinking less, we would expect to see a slower rate loss over time. And so along these lines, Misty, our veterinarian, suggested measuring hematocrit as a biomarker for dehydration, using the logic that if mice don't have access to palatable water, they may abstain and then show clinical or subclinical signs of dehydration. So then we also had to look at the water quality. We did internal testing for E. coli and coliform bacteria, and then sent samples to an external lab for bioburden and microbial analysis. And then all of these factors are influenced by the number of mice in the cage. So the number of mice in the cage will affect how much water is consumed and then how long these bottles last. So we wanted to look at 3 different caging densities. We chose cages that were high density with 5 female mice, then low density female mice, which was 2 mice per cage, and then our worst case scenario, singly housed male mice. We didn't look at singly housed female mice because we usually socially house females as much as possible, but males often end up singly housed due to aggression or breeding males. So we did expect with this set of cage densities that we would get a wide range of time. The study was then conducted in 2 parts. We first conducted baseline measurements of these metrics over the standard weekly bottle change. Then we waited 2 weeks in between and then set up the same mice for the same metrics and then allowed the bottles to remain on the cage until the volume reached 100 mils. And we just waited to see how long that would take and how the mice did over that time period. So we used 33 C57 mice and we grouped them based on different housing densities. So clearly the number of mice in each cage will affect how much water is consumed and how long the bottles last. So we tested these mice across 3 housing densities, choosing cages that were high density, which were 5 female mice, medium density, which was 2 female mice, and singly housed, which was 1 male mouse. We didn't test the singly housed female mice because in general, we socially house our females as much as possible. But in the males, they'll often end up singly housed due to aggression or breeding. And so given these parameters, we expected to see a wide range of time based on the cage density. The cages themselves were lined with corncob bedding. These also arrived pre-filled, and the caging system itself is disposable.
It's time for a quick break to hear about the AALAS Learning Library. Hey, are you ready to elevate your team's knowledge and skills in laboratory animal science? Well, the AALAS Learning Library is your one-stop solution for comprehensive training. With courses designed for everyone, you can train your entire team in one place, earn valuable AALAS CEUs and RACE CE credits, and take advantage of group discounts to maximize that investment. Getting started is easy too. Sign up for free to access select courses instantly to explore a vast library of resources. Empower your team, stay ahead of the field, and grow with the AALAS Learning Library, your trusted resource for laboratory animal science professionals. All right. Well, thank you for that really great summary of the materials and the design of the study. That is always so helpful to our listeners to really understand and make the paper really come to life. So thank you so much for all of that detail. So we're ready now to move into results, which is always what everybody is just waiting for. So we would love for you to just sort of take us through the highlights, what you found, and then also just identify things that maybe were kind of a surprise to you.
Sure. Based on the way these bottles appeared every time they've been discarded or thrown away, and based on the fact that the water is chemically treated to reduce the risk of contamination and microbial growth, we weren't too surprised with our results. So a little preview there. The range of time between our caging densities ranged from 13 days in the high density group out to 47 days in the singly housed male group. This is significantly longer than our standard 7-day bottle change. The rate of water consumption did not change between the 7-day baseline control period and the volume-based period for any housing density, regardless of group. And the weight of each animal in each group increased in line with the established weight trends. So we didn't notice any clinical observations, and all mice remained in good health, assessed by total body condition scores, which was really exciting. The hematocrit values for dehydration were also within the normal limits at both baseline and bottle time points. And then as far as water quality, there was no E. coli, no coliform, no aerobic bacteria, and no fungi found in any bottles, even out to 47 days. So bottles at the change remained clear and free of turbidity and cloudiness. So we were pretty happy with this.
Wow, that's a lot. And that is, you gave a really great summary for a lot of data there. And I think that's just wonderful that you were able to see results, that you were kind of hoping to see anyway. And I was a little surprised to see the length of time being as long as it was. So I really appreciate that. All right, so let's just sort of talk about the discussion. What were you guys kind of thinking when you wrote the discussion? You have some really good points that you brought up. And we always ask if, you felt like there were some identified study limitations. We'd love to hear about those too.
Right. Like I said, we didn't really find any adverse effects on animal welfare or the water quality from extending the bottles out even to 47 days. I think the most telling indicator of that is that the animals did not preferentially drink water at faster rates when the bottles were newer, and they didn't reduce their drinking from older bottles. So this allows us to move towards a volume-based replacement schedule, and that schedule enables those bottles to be changed really quickly by visual assessment at the same time as daily cage checks. And so a technician can move through the racks and replace bottles as needed and every morning, and it's a quick check. Whereas now, during our biweekly cage change, we don't have to fill the transfer station with bottles. We can actually just transfer the bottle from the old cage to the new cage. That still leaves a 4-day supply of water, which is in line with our emergency response plan, and it significantly reduces the number of bottles being processed for recycling on a weekly basis. So we are aware of 2 limitations with this study. The first is that we only offered the 1 bottle to animals, given that our available caging system only allows for us to provide 1 bottle. Follow-up studies may want to provide a choice for the animals between the new and the old bottles. And it may be worth noting that since the publication of this paper, there actually might be a new type of lid on the market soon. So that would allow potentially us to provide a choice for a follow-up study. And then another limitation, which might be more relevant to other institutions, is that we only investigated our disposable 300 ml bottles, which contained acidified water. We didn't measure the pH over time, and that might be relevant to studies or facilities that need to maintain a specific pH value. But other watering systems that use non-chemically treated water or automatic watering systems or bottles with even larger volumes may want to conduct follow-up testing as well. But getting back to our primary initial motivator, we saw a reduction in plastic and water waste. So even at high-density caging, extending the bottle replacement to 2 weeks would represent a 100% reduction in wasted bottles and water. And so the savings are even greater for lower density caging, where the bottles last for singly housed mice up to 47 days, and that would be a 600% reduction in waste. So using average pricing, if you look at a facility with 1,000 cages, depending again on the amount of mice you have singly housed, this represents a potential annual savings of over $30,000, reducing the plastic waste by 26,000 bottles and caps and water waste by 2,000 gallons. So we conclude that facilities, maybe have an obligation to consider environmental impact if your animal welfare is not compromised.
Well, thank you so much for that summary, Alyssa. I appreciate all of it. I kind of want to unpack it with you. First of all, the plastic waste and savings of that waste, that's staggering to me. That is something that I've never really been able to sort of quantify. And so I really appreciate that. I wanted to ask a follow-up on that alone. Does your institution or do you know of other programs that do any kind of recycling of that plastic?
Oh, yes. So our system is disposable, but it is recycled in a closed loop system. The bottles themselves are recycled through the municipal waste streams. And so that's why all of the water has to be emptied before the bottle itself can be recycled. So it's also an ergonomic strain because somebody is going to sit there and open up all of these bottles to dispose of the water.
Oh, that is a really good point. I really appreciate that because I know for some institutions, it's tough to get that recycling commitment. So hats off to you guys for being able to do that. Yeah. And then the other things you noted, just the staff time, staff labor, and stress to the animals, just, in general, in doing these more frequent manipulations of the cage. So I really love that. I would love to know how your program has implemented or adopted this wonderful data that you have.
So we've fully moved to a volume-based system. It gives us a lot more confidence in that 100 mil lower limit because we're able to get an accurate performance-based reading of the water consumption in our facility. And so it can justify to us that 100 mils is a good 4-day supply of water if necessary. And switching to the volume-based cage change or bottle change allows us to just very quickly change the bottles in the morning. Like I said, it's right there in front of you, and so it's not a separate thing that someone has to do. You just change it when it's low.
Yeah, I love that. I did want to ask also as a follow-up, was there a lot of pushback from your PIs into making such a change? Because, sometimes in programs, it can be a little tricky to make a change like this.
Yeah, everyone at Eisai has been very supportive, and especially once we were able to calculate the percent savings. There's a lot of buy-in because it's really about the environmental impact. We're really able to reduce up to 26,000 bottles out of the landfill. I'm sorry, that's not actually true because that's for a larger facility. I was trying to pick
Oh, got it. Yeah.
We're actually a smaller facility, so those don't represent our exact savings, but we are able to put a number on how many gallons we save and how much plastic we don't allow to enter the landfill.
Wow, that's great and very admirable. Well, we are coming to the end, which makes me sad because I've really enjoyed this. So we always ask our guests one final question. They're always kind of the same, so you probably know what this is going to be. But we would like to know what advice you would give somebody who wants to do a similar type of evaluation, probably geared towards water bottles, but could be sanitization of water or something like that. But a similar sort of evaluation in their facility. What advice would you give them?
Definitely don't shy away from conducting performance-based evaluations for deviations from the standard practices. Every facility is different. A well-designed study can really support changes that make a substantial improvement in operations and also environmental impacts. And the other advice is that we're a smaller program. We have fewer than 1,000 cages ourselves. Don't think that your program is too small to make an impact.
Oh, that is so well said. I really appreciate that. You're right. I love it.
Thank you.
All these great nuggets. Thank you so much. Thank you for being here. Thank you for having a great team there at Eisai, and thank you also for putting this paper in JAALAS. We love it. We're so excited to highlight it here to our listeners today, and we want to encourage you to submit more. So thank you.
Thank you for having me. And I hope that this is a helpful paper for other institutions who are looking to do something similar.
Thanks for joining us on The Last Word, the official AALAS podcast dedicated to advancing laboratory animal science. We really hope you enjoyed this episode. To find out more about this guest or the conversation, download our show notes wherever you access this podcast. And please join us for our next episode. Until then, stay curious and stay connected.